Okay, so I forgot where I left off, but we're talking about how do I efficiently remote control, how do I efficiently run applications to a corporate network through a VPN connection, given the fact that the applications that I need to run are going to take up huge amounts of bandwidth, not just browsers, not just browser refreshes, those kinds of things. What would I use? What tool? We've already talked about it. What tool? I connect to the VPN, and then I want to connect to the network and run applications. What would I use? Jason?
Is it the Windows desktop?
Yes? On what kind of server? Huh? Nope, not an RS server. Okay, it's the two technologies brought together. Okay, I've got an RS server that gives me the VPN, or I've got a firewall / router / security device that gives me the secure connection back and forth. What I need to do is include the technology of remote desktop services. So on the other end, on the corporate network, sitting off in a corner someplace, doing nothing but provide those services, I've got a remote desktop server or terminal server sitting there. I remote into that terminal server, and I am basically the same as sitting at that physical machine. I'm going to give you a demonstration of that. Okay, so as an example, I have a client here's a great example, a perfect example. I have a client in Benton Harbor, Michigan, Portage, Michigan, Allegan, Michigan. They have 3 offices. I have a client that is an architectural firm. They've got a bunch of architects and a bunch of engineers. And their machines that they work on are $5,000 PCs because they've got unbelievable video card. Think about your ultimate Alienware gaming PC, okay? That's what they have, because AutoCAD, how many are familiar with AutoCAD? How many do not know what AutoCAD is? Be honest. Okay, AutoCAD is a program that allows you to do very detailed drawings and specifications for construction, well, for a lot of different things. But an AutoCAD drawing will have multiple layers. If I'm going to build this building, I would use an AutoCAD drawing. Okay, the AutoCAD drawing would have a layer for the electrical plan. It would have a layer for the plumbing and heating. It would have a layer for the general physical walls and ceilings and all that kind of stuff. It would have, and out of an AutoCAD drawing, you print out blueprints. Everybody knows what blueprints are, right? So when you go on site to build something, you have a set of blueprints. Well, AutoCAD is what creates blueprints. So you can imagine the files are not 5 megabyte files, 10 megabyte. These are gigabyte files, huge files with all this different detail in it. And so especially when they start doing 3D modeling, these AutoCAD geeks will bring up their drawing and they'll spin it and turn it and do all these kinds of things. That's a huge amount of data being transferred back and forth. So with remote access services or terminal server, it allows me to remote control to that guy, to that remote desktop server through a VPN connection, think small bandwidth, take over that computer, run the AutoCAD programs from that computer, and look at all these intricate designs. The only thing that's passing back and forth between me and that computer is screenshots, mouse clicks, keyboard clicks. No data is being sent back and forth other than those, okay? So I'll give you an example of using a remote desktop server. As I said before, if I want to use this effectively, oh shucks, hold on. If I want to use remote desktop services effectively, what's the first thing I need to do? I'm on the internet. What do I have to do? Jason's the only guy with his hand up. What do I have to do? Aaron.
Establish a VPN connection.
I can't hear you, buddy.
Establish a VPN connection.
Establish a VPN connection. So let me, first of all, get this on screen. Okay? So the client that I'm going to use is not an RRAS client, but instead it's going to be a client that's available for the firewall that's on the other end. It's called SonicWall Global VPN Client. Okay, so I have an IP address, and that IP address may be a problem if it's the same as what I have here. So here in the school, wireless LAN, I've got 10.40. Okay, I'm good. Because at the other end, my IP address is 192.168.255.45 at whitemanassociates.local. Okay? So my IP address is good. I can ping devices on the other end. Ping x1-rdp.whiteman-assoc.local. What is that an example of? That typing that I'm doing at the bottom here? What is this right here? This x1-rdp.whiteman-associates.local. What is that called? Yes?
Is it like the computer name on the other side?
It is a computer name, but there's a more accurate name for that. So what's it called? Yes?
The domain name?
That's part of it, but not all of it. Michael? Fully qualified domain name. It's got a host name, which is x1-rdp, and it's got a domain name, which is whiteman-assoc.local. Okay? So if I ping it, I'm getting a reply from 192.168.0.162. So IP is working properly. So now that I've got to configure it, now that I've got a connection to their network that is encrypted, I can now connect to a remote desktop server at the other end. I happen to know that that one that I just pinged is a remote desktop server. I still have network security, just like I would if I tried to log into the network on site. So I not only have my VPN security, but I also got network security. Now let's see if the school has blocked port 3389. Nope, we're good to go. Okay, so now I'm running, this whole session is a remote desktop session on a Windows Server 2012 machine at the other end. Now, at the same time I'm doing this, this server is good enough, big enough, strong enough, fast enough that I could have 5, 6, 7 other users on this same server remoting in at the exact same time. Each of us have our own session going on. I'm running AutoCAD, they're running Revit. I'm running Word, they're running Excel, PowerPoint, and everything else. So we're all on this server at the same time, but I can run whatever applications I want to run. I can manage the server, I can open up programs. Now, I don't know anything about AutoCAD, so I'm not going to do that, but I could run it if I wanted to. Okay? As an IT administrator, as an example, this Unify application is a tool that I use to manage the wireless access points throughout the school, throughout the business at the different locations. So I'll run this. I haven't run this in probably 8 months, so let's see if it runs okay. It's starting Unify controller, trying to connect to it. As soon as that becomes available. Now this particular program, okay, it started, is run from a browser interface. So I'm running Internet Explorer at that location. And I'll have to look at my documentation for the username and password, but you get the idea, okay? I can run, let's see here, I'm trying to get off of this window. There we go. Windows Server 2012, as you can see, looks an awful lot like Windows 8.1 and acts like Windows 8.1. Here's one. Here's something. So this Microsoft Management Console, if I want to manage this server, if I want to change users, if I want to do whatever I need to do, I can do from here. It also gives me an in to get to all of the other devices on the network. So if I want to control this server from here, I can control all the other devices on their 200 station network. Okay, you get the idea of how you can use remote desktop services. Okay, let's as you can see, sometimes when you're dealing with a small screen here, sign out. Now, if you notice, the remote desktop session is off, right? But I still have my VPN connection. So the other thing I have to do is I need to close my VPN connection. So now if I go back and ping x1-rdp.whiteman-assoc.local, could not find it, right? Because I have no DNS server resolving that. So I can't even find the host, let alone ping the IP address. Okay, so you get the idea. All right, let me disconnect from this and connect the slides again. Oops, I don't want that, sorry. Okay, so again, why is that not projected up there? There we go. Again, what does RAS do for me? Remote access service? Austin.
It gives you a tool/place you can connect to take control of.
Now you're thinking remote desktop services. What does RAS do? Where do we use RAS? Come on, guys. When do we use RAS? Ebert. When did we use RAS? Yes, but what did I use it for back in the day? Come on, think back. When? RAS, when did we use it? Yes?
Used it when Novell didn't have.
I used to, RAS was a service that ran on a Windows server that allowed me to connect to another network. It could be a Windows network, but back in the day when it was just RAS, it was to connect to the Novell network. Now we have something called RRAS. RAS no longer exists. Remote access services no longer exist. Remote routing and remote access services exist. What routing and remote access services added to the equation was VPN. And VPN means what? And virtual private network, what happens to the packets? They become what? It's security. They become what? What do we do to the packets, Johnny? Encrypt them. That's all I was looking for. Encryption. Okay, RRAS gives us encryption. RRAS gives us an endpoint at the other end, among other devices, gives us an endpoint to connect to. Back in the day, we used RRAS with dial-up connections. We used RAS with dial-up connections. Now we have high-speed internet between me and the other end of that. Okay? Okay, dial-up connection, VPN connection, you got it. This is the interface for routing and remote access. You do not have to know how to configure that. Okay, just understand that that's what that screen is. Okay, when we encrypt a packet, when we establish this VPN connection, we have to have, remember we talked about the 7 layers of the OSI model? Each layer had its own set of protocols that were associated with it, right? Everyone had its own level. Layer 2, we would use we would use MAC addresses, right? Layer 2 on the OSI model is MAC addresses. Layer 3, networking is where layer 3 is. So we use certain protocols. Layer 4, we would use TCP and UDP. Those are all TCP/IP protocols that are in the suite of in the TCP/IP suite. Those are individual protocols that are used. With VPN connections, we have protocols that are associated with that also. One of those protocols that allows us to encrypt packets is called IPsec, Internet Protocol Security. Know this. IPsec is the protocol that allows me to encrypt. It's actually the protocol that encrypts the packets. This is the magic behind the VPN tunnel. Now, we have different types of tunnels. Just because I have a tunnel doesn't mean I have encryption. Okay? Think of it like this. Remember I told you before, when we do a VPN, pay attention to me, forget the notes. Pay attention to me. I like attention, okay? Remember I told you to imagine me connecting a wire across the internet from here to my house. If I do that and I plug it into my computer, I've now established what we call a tunnel, VPN tunnel. That doesn't necessarily mean that the packets are encrypted, any more so than the packets here are encrypted across this wireless access point, or if you plugged in to a wired connection on here. They're not necessarily encrypted. I don't have to encrypt the packets here. In a normal business environment, I don't have to worry about encrypting the packets on my network because it's secure. I have physical control over it. But on the internet, I need to worry about that. So I run the cable. I've now established a tunnel. There are two types of tunnels that you need to be aware of. One, layer 2 tunneling protocol. Layer 2, L2TP. Layer 2 tunneling protocol. Now you can type. The tunnel itself, think of it as the wire, the tunnel itself across the internet or any not secure network, okay? One of them is L2TP, Layer 2 tunneling protocol. It is not by itself secure. It simply establishes that connection. Layer 2 tunneling protocol with IPsec, and you'll see that referred to a lot, L2TP with IPsec, provides encryption. So if you get a question on your test, you're an IT administrator and you have connected to a network using Layer 2 tunneling protocol, and an auditor comes in and fails your audit because why? 1, you're not able to control things. 2, you failed to encrypt packets. 3, or C, the ports aren't open. I'll make up whatever. The answer is, if you just use L2TP, you have not encrypted squat. And so you've got packets that are flying back and forth across the internet, waiting for any wannabe jihadist, okay, Al-Qaeda, ISIS, ISIL, whatever you want to call it, whack job, waiting for them to grab those packets, sniff them, and then plant a bomb someplace based upon the knowledge that they've gotten. Worse yet, they'll steal your social security number and fund the bomb that they plant someplace else. Okay, so we want to encrypt packets. We use IPsec. The second type of tunneling protocol used, the second type of tunneling we use is called PPTP, point-to-point tunneling protocol. It's an older protocol, Microsoft only. It did automatically include encryption. Nobody uses it anymore. It can be used, but nobody uses it anymore. If we're going to use RRAS, a lot of times we'll use PPTP. Okay? Those are the things you need to remember about encryption. Good. With IPsec. And what's IPsec again, Austin?
IPsec is Internet Protocol Security.
What does it do?
What does it do? Oh,
Forget the notes. You should know
okay.
this.
I just want to make sure it encrypts.
I'm not going to yell at you.
Okay. It encrypts and authenticates.
It encrypts packets. Okay? Encrypts packets. It secures it from Al-Qaeda. All right? Everybody can remember that. Everybody got that? All right. How does it do it? There are 3 areas. Okay? 3 areas. First one, security association. So here's the situation. Anybody ever do this as a kid? You come up with a secret code that only you and the other guy know, and you send messages back and forth. You're still doing it? You passing notes back and forth, is that it? Okay, you send notes back and forth. You know, the earliest one as a kid is Pig Latin. How many know Pig Latin? Come on. I'm the only guy in here except for Austin who knows Pig.
What is
Johnny, I don't talk to your girlfriend.
Good morning, Plymouth High School. This is Mr. Condon. I'm greatly sorry for the interruption, knowing that today is ECA testing. I do want you to be aware that we had a fire alarm pole station that was damaged yesterday, and the guys are working on that. Anytime you work on that, because they are so sensitive, there's a possibility that the alarm could go off. I want you all to disregard an alarm if in fact it does go off until further notice. Once again, if the fire alarm does go off, disregard it until further notice. Thank you.
Okay, so first we establish security association. Here's how this works. In the whole VPN establishing, you got the tunnel and all that kind of stuff. Now you're in the tunnel. Now the next step in all of this in the IPsec security thing is to do the security association. All right, so here is, I want to have a secure communication with Jason. Here's where Jason and I are going to agree. Hey Jason, are you going to use Pig Latin, or are you going to use a simple letter replacement kind of strategy to do this? Just give me an answer. Okay, all right, so you're going to need a key on what letters to replace when I send you the message. So I'm going to send you the key. All right, have you got the key? Great, you get it back to me. We're now working off the same sheet of paper, the same level of, we've established our security association. Now we've established the rules by how we're going to do this. Okay, now, next step is the authentication header in this whole process. At this point, this is the authentication header. He knows it's me, I know it's him, right? We've established that, and that authentication header, part of that protocol, is responsible for making sure that when things go back and forth, they're adhering to the rules, and if something gets screwed up, it's sent back and forth, it's sent again so that I can, in other words, if I miss a packet, or if I miss part of that communication, authentication header is responsible for getting me that information again, keeping track of it. Provides connectionless integrity in the authentication of data. Also provides protection versus replay attacks. So replay attack would be Jessica jumps in the middle of this and sends back the information to Jason, and authentication header would recognize that it's her and not me doing it. The third part of the whole equation is ESP. ESP is actually the part that encrypts the data. So even if everything else goes to pod, if someone grabs that packet, they cannot decrypt that packet. That's what ESP does. Okay? Questions? If you know those three things, you'll be fine on IPsec for my test. All right, now we're going to completely shift gears. This is extremely, extremely important. We've talked about it in the past. We're going to go through step by step how DNS works. Why do we care about DNS, Josh? Say, okay, why do we care about DNS, Josh? You're right. You don't know why it's important. Why do I care about resolving hosting's IP addresses? Huh? Take it one step further. Keep going, Josh, so I can see the other connection.
So like, if you really were computing from, you want to see if you had, you did like a demonstration a website, yeah, a website.
Okay.
But you repeated, you know, it was like patch or
Okay, so you're talking about stuff that is not wrong, but you're missing the basis of what DNS is all about and why we use DNS. Get more generic. Austin.
So that you can go to your search browser with your browser never type in www.google.com and it'll pull something up.
So I can use names instead of having to memorize a jillion IP addresses. So I can use names. Not just for web browsing, but anytime you communicate on a network. When I map a drive, when I want to get to one of those AutoCAD drawings, I know that those AutoCAD drawings are on the project's server. The server named projects.whiteman-associates.local. I know that if I want to run AutoCAD in a remote desktop server, I can remember x1-rdp.whiteman-associates.local. Every computer on the Whiteman network is called computer name .whiteman-associates.local. That's a fully qualified domain name. I know that if I want to get to the accounting application, I need to connect to ACCTG, which is the name of the computer or the server, .whiteman-associates.local. Okay? I can't remember the IP addresses for all of those. 192.168.50.24 is the only one I remember because that's a domain controller. I can't remember all of those individual IP addresses. So Microsoft and the world, anybody that's involved in any kind of computing, has established DNS as their standard for being able to communicate. Okay? So DNS is not just a Microsoft standard and a Microsoft service. DNS has been used throughout the world. We started out, the internet, okay, started out as what kind of a project? Anybody know?
Yeah,
Okay, this ought to be good.
a DARPA project.
What is DARPA?
DARPA is based, I don't remember the acronym, but it's basically America's advanced weapon testing type thing.
Yeah, that's a bit of a stretch. DARPA is a governmental organization. Originally, the internet came about through a couple different means. One, the government said we need to be able to communicate in time of war with the Soviets. In times of war. We need to be able to communicate long distances with, what's that? Go ahead.
I said in times of war, Soviets.
Yes. Communists, all right? We need to be able to communicate in times of war. We need to be able to communicate across long distances. So we're going to come up with something. We're going to use the colleges to develop this because they've got something going on in the background of the past. Okay, so in the beginning of the internet, we had a handful of computers communicating across telephone lines, or a handful of computers communicating across, well, telephone lines, okay? It was easy to keep track of, let's use them by name. Let's pretend that Christopher's at Berkeley, Austin is at NYU, and Taylor is at, give me another one.
MIT.
MIT, yes, MIT, Massachusetts Institute of Technology, okay? I can remember Taylor, or I can remember his IP address, 192.168.5.6. I can remember his, 197.3.4.6. When it's 3 computers, that's easy. Okay, but then it started growing, and they needed some other way of being able to communicate. So what they did was, they copied host files. You gotta remember this, memorize this. They created something called host files. Do you know what a host file is? Y'all have them on your computers. Okay, everybody go out to Windows Explorer or File Explorer, whatever it's called. Okay, go to your C drive, My PC, down, My PC, or this PC, left side. Okay, C drive, double click on your C drive, double click on Windows, double click on System 32, scroll. System 32, up, yep. Then go to drivers. Is that alphabetical? Drivers, double click. Go to etc., etc. And double click on hosts. Okay? This file, this host file, is nothing more than a text file. You need to know what it is. It probably doesn't have a whole lot of anything other than, you'll use Notepad to open that, by the way. Doesn't have a whole lot of anything other than perhaps your, yes, loopback address. Okay, but it gives you the structure to be able to resolve a host name to an IP address. So pay attention. Here's how a host file works. In this text file, you'll have a name, and in this case, it's austin.berkeley.com, and then beside it, you'll have a registered IP address, 192.168.whatever. Okay? In addition to that, his host file will also include Taylor's IP address and host name, and Christopher's IP address and host name. Okay? So that if he wants to communicate with Taylor.berkeley.com or whatever his computer is, he's just going to type in Taylor.berkeley.com, but the computer is going to resolve that. from a host name to an IP address so that it can communicate using TCP/IP. All right? So that's fine for 3 computers. Yes?
Is there a way to take screenshots and
Yes.
Is there a way to use, yes, screen, you've got OneNote loaded, lower right-hand corner. Yes, so lower right-hand corner. Question was, how do you do a screenshot? I'll show you. There are a couple different ways. My personal favorite is, first of all, you need to be able to see, can you see all of the icons down here in the lower right-hand corner of the taskbar? There's one called Send to OneNote. If you right-click on it, take screen clipping, Windows Shift S, or Windows Shift 5. No, that's S. Okay? Then you click and drag across what you want to do. Now, by default, it will, on your computers, it'll probably bring you up to like a OneNote, where do you want to place this? But instead, you select Copy to Clipboard. And then you can paste it into your page. Are you following, Jason? All right, so now we get all that. Okay, so we have host files on all of these computers that are connected to the internet. That's fine, but how do we copy those host files back and forth when it starts growing to 500? Now you've got to have 500 listings in there with IP addresses. Then it starts growing, you've got 1,000. Well, you can see right now that those host files become so much bigger, and as these IP addresses change, and as hosts get added, it was difficult to keep those, and this is how it worked. It was difficult to keep those host files up to date. So instead they came up with a scalable feature, or the scalable service called DNS, Domain Name System. Domain Name System. And Domain Name System allows us to get out on the internet and resolve any host name for any registered IP among billions of computers like that. Okay? Very, very, very quickly. In addition, DNS is used by Microsoft for local area networks. You don't even have to be on the internet, but we still use a different version of DNS, Microsoft's DNS, to be able to resolve computers on a local area network or its own private wide area network. We use it for the internet, and then there's a replica system that Microsoft does that we use for local, or for your own IP addresses, or its own network. What?
What about like LAN? I was thinking about this, like if you had like LAN party.
That's why I just said local area network.
Yeah, I know.
LAN.
But like besides just searching for files, I was thinking like, I know you don't like when I use video games as like an example to think about this. Say people were having like a LAN party, had a bunch of Xboxes connected to each other. For them to be able to like
Use DNS?
yeah, would that be DNS as well?
You could, absolutely. So if you have a LAN party and you're using Microsoft Windows as the basis of that, you would have a server that's running DNS. Okay? It's got the DNS server service running. Everybody comes in, they bring their computers, you tell them, here's your host name, here's your IP address, and you manually type that information into the DNS server, and that way everybody around here can connect to Jessica, can connect to Jill, can connect to so on and so forth. You get the idea. Or, if you're all part of the same domain and you allow it, when those machines boot up, their DNS client goes out and finds the DNS server. How's it go out and find the DNS server, Larry? How's it know where the DNS server is? How's it find? How many know how it knows where the DNS server is? You boot your computer up on the network, you get your IP address, and now you need to register with the DNS server your host name and IP address. How many know how that knows how to find the DNS server? I'm going to cut my wrists and never teach again. Johnny. No, that's how it gets its IP address, and subnet mask, and gateway, and huh?
Or the second default.
I'm not saying default. It's DNS server. When it got its IP address to begin with, it received the IP address of the DNS server that it's supposed to communicate with. And it got that from the DHCP server. So Johnny was almost there. Okay? Back to the history of the internet. So, we now have this huge system called DNS that allows me to go out and find the IP address of a registered host or a registered domain almost immediately if I'm on the internet. Do you have a question? No? All right, so how does that work? Let's take a host name. Let's see if there's a slide first. That way I won't have to draw. There isn't? We'll create one. There is none. Okay, very briefly. Let's take a host name, fully qualified domain name. Give me one. Frank, give me a fully qualified domain name, loudly.
192.
No, it's an IP address. Give me a fully qualified domain name. We just covered this. Michael Ebert. Huh? That's a domain name. Give me a fully qualified domain name. You're almost there. Michael. PHS 135. What did you say? At Crossroads? Nope. Nope. PHS 135, which is the name of his computer, let's say. Dot Plymouth. Dot K12. Dot IN. Dot US. BHS 135 dot bps.k12.in.us. L 135 dot unorth.k12.in.us. Those are fully qualified domain names. Computer 1 dot microsoft.com is a fully qualified domain name. Computer 1 .sales.redmond.microsoft.com is a fully qualified domain name. In those names, we know exactly where those devices sit within the hierarchy. Okay? Very easily, Michael's computer could be phs135.highschool.plymouth.k12.in.us. There could be a subdomain for just high school. Each one of those layers, Microsoft.com or phs.in. Okay, so let's take the name phs.in or plymouth.in.us.com. .com, everybody's sharing that. What's that called? .com, .net, yes?
HTML. Why did I say that? HTML.
No. What is that called? In DNS world, does anybody know what that's called? Huh? What's those of you who are wannabe hackers, what is the all-encompassing, most important user account? I am, huh? Not admin. Linux. Think Unix, Linux. No one knows this? That's good. Yes. Taylor. Yeah. Austin is not a hacker. He just goes to sites he shouldn't go to. And they download stuff on his computer that turns him into a hacker by association. Root. That's a root domain. Okay? Top level domain. Root domain. The dot is the root. .com is the top level domain. Then you have things like Microsoft, which you have to register. How many have registered a domain name before? No one? No one's ever you've never registered a domain name? Never put up a website and registered a domain name?
Oh, yeah.
Yes, Q, what is it? Homestead Dairy?
Yeah.
Okay, homesteaddairy.com. How did you do this? Sound off so everybody can hear you.
I went, well, I don't know what website or whatever we use, but you know Roland, right? I went through him and he just helped me set it up. I don't know.
Okay, so homesteaddairy.com. If Q wanted to do that, he would have to go out to do a I'm not going to get into, I can go on for days on this. He went out to a registrar, and there are only so many that are on the internet. One of them is Network Solutions. One of them is, who's the one that does the Super Bowl commercials? GoDaddy. Another one is Register.com. These are all companies who have direct lines of communications with ICANN, I-C-A-N-N. And so if I want to register a domain, there are a couple things I need to know. One, I need to know a domain name that's unique. So in my case, I've registered a lot of domains. Crossroads Academy is one. CrossroadsAcademy.com. I own that, okay? IntegrationGroup.com. I own that domain. I'm responsible for it. No one else in the world can use it. HoosierDriving.com. I own that. HoosierITS.com. HoosierITServices.com. FeastFamily.com. I own those domains. I registered those domains. I paid a fee to a registrar, and now I own those domains. I can also create subdomains. So say, for example, I turned into a multi-billion-dollar corporation. I would have us.HoosierITS.com as a, not as a computer name, but as a subdomain name. So if I put a computer in that us.HoosierITS.com, or a computer in that Germany.HoosierITS.com, the computer name would be computer1, or whatever the computer name is, computer1.germany.HoosierITS.com. Okay, you get the idea. That is a fully qualified domain name. The Germany part is a subdomain of HoosierITS.com. Yes?
Two questions. First one, like,
Sound off so everybody else can hear.
could, for fully qualified domain names, can I put phs.135.1.8?
Well, only if 135 is a subdomain of, no, it has to be in the right order. The farther left you get, the more specific it is. Does that make sense? The farther left in the word that you get, if you're looking at the name, computer135.plymouth.k12.in.us, the more specific it is. You had two questions.
Second one, would like
Sound off.
blog be considered a domain name?
Blog.com.
Like mfeast.blogspot.com.
Okay, mfeast.blogspot.com. mfeast is a site or a computer on blogspot.com. So you went to Blogspot, if you did this, and said, I want a subdomain called mfeast. Well, probably what they're doing is they're assigning a host name, which is actually probably a page on blogspot.com only, but it has an IP address associated with it. Okay, what's more likely is you're going to get www.blogspot.com/mfeast. Okay, because then it would be a page within a website. Question?
Say you were trying to connect to a fully qualified domain name, do you have to have the subdomain name included?
You have to have everything. A fully qualified domain name includes the host, all of the subdomains in order, and then the root domain. It has everything. Otherwise, there's no way to navigate to it. Yes?
Could you explain what SSL certificate is?
Not yet. That's totally, we did that in a couple chapters ago. But SSL certificates are used in association with a domain to secure communication back and forth. I think it's kind of like IPsec, but different. Okay? Is that close enough for now?
Yeah.
All right. So I've got the subdomain, I've got the domain, I register the domain. Let's say feastfamily.com, I've got the domain. Right? It could be feastfamily.net, feastfamily.biz, feastfamily.org, it could be any of those. When I registered, I paid feastfamily.com. Jessica could turn around and register if she wanted, which she wouldn't, feastfamily.org, because that's not taken. Right? It's unique. When I registered that, I said, I want to use this server as my DNS server, my name server. DNS server, name server are synonymous. Name server, DNS server are synonymous. Name server, DNS server are the same, synonymous. Okay? I had to tell the registrar, which I use Never Solutions, I want to use this IP address for this name server to keep track of my feastfamily.com. Okay? That's the second step. You tell it what name servers are, you want to type this down, authoritative. Authoritative. What name server is authoritative for a DNS zone? Now, so far, the only zone I've got is feastfamily.com. I had to tell them what is the DNS server that is authoritative. I had to do that by either hostname or IP address. Well, I chose to use the same company. So I said, okay, name server equals ns1.neversolutions.com. Okay? Now, then, let's say I've got a computer that I want to make as a web server. Now we got all the issues of securing it, putting up the web page. Am I going to use HTML, or how am I going to use HTML, or use what tools am I going to use to create the web? Those are all separate. I need to have this computer out on the internet with a dedicated IP address that's associated with feastfamily.com. I'm going to call that server, what would I call that server? This would be a public, what is the host name that I would associate with that server if I wanted everybody to be able to get to feastfamily.com's website? What would I call that server? What host name would I give it? No one knows. Yes? US, did you say? No. If I have a company, HoosierITS.com, and I want to know that everybody can get to my website, I can name it anything I wanted, but the name that I want to give it, so people would automatically think, oh yeah, I would